Welcome back to The Explainer. Today we're diving into a fascinating, invisible battle that's happening literally all around us, and, well, even inside of us. We're talking about the ultimate chemical showdown: acids, bases, salts, and the pH scale. So let me ask you something. What on earth do lemons, a bar of soap, and your stomach acid have in common? I mean, on the surface, they seem completely unrelated, right? One's a citrus fruit in your kitchen, one is for washing your hands, and one is literally digesting your lunch right now. But, as we're going to see, these are actually prime examples of the dramatic chemical extremes that govern our daily lives. They're all major active players in this chemical showdown we're exploring today. All right, to understand this showdown, let's meet our very first chemical character: acids. You've probably heard the word acid thrown around in sci fi movies or cleaning commercials, but what actually gives an acid its power? Well, fundamentally, an acid is just a substance that releases hydrogen ions when it's dissolved in water. That's really the secret sauce to their behavior. When an acid hits water, it just lets loose these tiny hydrogen ions. And those released ions basically become the active engine behind absolutely everything an acid does. And because of those aggressive little hydrogen ions, we physically experience this invisible chemistry in some very specific sensory ways. First off, they taste sour, like really sour. Second, the strong ones are volatile enough that they can actually burn your skin on contact. No joke. And finally, there's this famous chemical test for identifying them. If you expose a piece of blue litmus paper to an acid, the reaction physically changes the paper's color, instantly turning it red. Now, we interact with these abstract traits all the time. That sharp, sour taste we just mentioned? Yep, that's citric acid, giving lemons their signature pucker. Then you've got acetic acid, which is the primary ingredient in the vinegar sitting in your pantry. And what about that aggressive burning trait? Well, believe it or not, that is safely contained inside your own body right now in the form of hydrochloric acid. It's the powerhouse substance in your stomach actively breaking down your food as we speak. But, an acid is really only half the story here. Enter the opposing force: bases. Unlike acids, which release those hydrogen ions, a base is a substance that releases hydroxide ions when it's in water. That is their distinct molecular signature. And here's a fun fact: there is a specific term for this interaction. When a base successfully dissolves in water, it's called an alkali. So if you ever hear the word alkaline thrown around, you instantly know you're dealing with a water-dissolvable base. Now, just like our acids, bases show up in the physical world with very recognizable traits, but they act as a stark contrast. Instead of tasting sour, bases taste distinctly bitter. To the touch, instead of burning, they have this remarkably slippery or even soapy feel to them. And when it comes to that litmus paper test, bases do the exact opposite of acids. They'll take a piece of red litmus paper and turn it right back to blue. It's honestly like a perfect mirrored opposition in chemistry. On one side of the ring, acids are sour, they burn the skin, and they shift blue litmus to red. And on the completely opposite side, bases are bitter, they feel slippery, and they shift red litmus to blue. The striking sensory and visual dichotomy between these two forces is just perfectly balanced. And we rely on these slippery, basic substances just as much as we rely on acids. Sodium hydroxide, for example, is a totally key component in soap, which perfectly explains that distinct slippery physical feel we were just talking about. There's also magnesium hydroxide, which is commonly used in antacid medicine to, settle your stomach. And of course, we can't forget that absolute classic household staple, baking soda. So the big question is, what happens when these two total chemical extremes finally meet? Well, you get neutralization and the creation of salts. Neutralization is basically the process that happens when an acid reacts directly with a base to form a salt. And the word neutralization is pretty much spot on here, because these two extreme opposites literally cancel each other out. The fierce, sour, burning acid and the bitter, slippery base suppress each other's extreme traits to create something entirely new and entirely balanced. And this isn't just some boring, static equation on a chalkboard. It's a dynamic, active collision unfolding in real time. You take your powerful acid, you introduce your basic counterpart, and the exact moment they combine, boom, that neutralization process triggers. The final outcome of that whole chemical synthesis is the creation of a salt. Now, the physical properties that actually emerge from this reaction are genuinely fascinating. Think about it. You're mixing two highly active liquid extremes together, yet the neutralization process yields solid crystals. And not just any solids either. Salts are typically solid crystals with incredibly high melting points. It's a massive physical transformation from these volatile liquid extremes into a highly stable, solid state. And this leads to an absolutely mind-blowing realization when we look back at the everyday substances we've been talking about. If you take hydrochloric acid, that incredibly powerful acid found in your stomach, and you combine it with sodium hydroxide, that slippery base found in soap, they actually neutralize to create sodium chloride. And what is sodium chloride? It's common table salt. Crazy, right? The very same salt you literally sprinkle on your french fries is the neutralized offspring of stomach acid and soap ingredients. All right, so to categorize all these wild reactions, we need to zoom out a bit and look at our universal measuring tool, the pH scale. The pH scale is basically a direct measurement of exactly how acidic or basic a liquid is. Think of it as the ultimate measuring stick for this entire chemical battlefield. It allows us to assign a strict, universal numerical value to exactly how much power a specific acid or base is actually packing. The entire spectrum of everything we've looked at today runs along the super concise scale, from 0 up to 14. Values falling from 0 to 6 are acidic, with 0 being the absolute strongest possible acid. On the far end, values from 8 to 14 are basic, with 14 representing the strongest base. And right there in the exact middle, the perfectly balanced pivot point, is a pH value of exactly 7. That is true neutral, perfectly embodied by pure water. So we've seen the sensory properties, the neutralizing reactions, the everyday examples, and the scale that governs the whole shebang. But understanding these physical traits is really just the beginning of the journey. The real question is, would you like to see some chemical formulas for these? Because once you do, you truly start to see the hidden mechanics of our universe. Anyway, thanks for joining me on this explainer to unpack this epic chemical showdown. Keep analyzing, keep learning, and I'll catch you next time.